Welcome back to my YouTube channel. Let's solve the next problem given at IMO 1987. So we have Pn of k, the number of permutation of the set 1, 2 until n, that have exactly k fixed points. We have to show that the sum for k from 0 to n of k times Pn of k is n factorial. So the key idea of this problem is to use double counting. So double counting is a method which can show us a way of finding some relation between expression counting a quantity in two ways. What I mean by that? So we will have a quantity S, yes, and we try to use two different methods. So here is method 1 and here is method 2 to count the element of S, and in most of the case we will arrive at A. We say A weighs and B, and right now we will have an equality here. So how we will use this method? So hard part of this type of solutions is to find what quantity to count in two ways. And in our problem, our quantity, it will be the number of fixed points. So S, our S is going to be number of fixed point of all permutation. And I will count in two different methods. First method, I will fix an x from 1 to times n, and we will try to see in how many permutations it is a fixed point. So it remain n minus 1 elements which can be permute in n minus 1 factorial permutation. So x is going to be fixed points in n minus 1 factorial permutation. And because we have n of x, we will find that there are a total of n factorial fixed points. After that, I will fix a permutation. So we will fix a permutation sigma, and right now what we are going to do is to find how many fixed points this sigma has. So if sigma has key points, key fixed points, it will contribute in total with k times how many permutation has exactly key fixed points. And because k is from 0 to n, we will have a total of sum for key 0 to n of k times Pn of k. So we have here n factorial, we have here this sum, so we will have an equality that we want to have at the beginning of the problem, because that's what the problem says to us. So look, it is a very classical problem of permutation. Also is a problem which shows us some good insights on double counting. Double counting is a method which sounds easy and it is hard. Why? Because when you see that find that quantity to double count is a difficult part. How you count maybe is not so hard, but how to find that set, yeah, is not an easy part. But with a good experience and a good knowledge of the example of good ads, good sets, I think you can manage it to find that. Well, thank you for listening. If you're not subscribed yet, please share, like, subscribe to my channel. See you next time. Bye bye.